Okay, so in this class, exercise 6.2 introduction will do that. There will be no test for this, okay? In this section, we'll discuss some theorems, okay? So here, the first theorem, number 1. This one, this is under the subsection, lines and parallel lines and transversal. So here, first one is the theorem. If a transversal, write it down along with me, transversal intersects, if a transversal intersects two parallel lines, okay, two parallel lines, then each pair of corresponding angles, then each pair of corresponding angles are equal. So this is a theorem we're going to use in this chapter, okay? So write it down. And so let us draw two lines that are parallel. Let us say they are AB and CD, cut by a transversal, let us say E, F at a point G, and at a point H here, G and H. So what does this theorem mean is this, just follow, you will get it. So if these two lines are parallel, be parallel to CD, these two lines, as you can see here, okay, and are intersected. Okay, and let's just write in simple form, and transversal, let us say. Transversal means a line only that cuts the given sets of line. A line that cuts the already given lines is called a transversal. And transversal, EF intersects, AB and the line CD and G and H respectively. If this is the case, then this theorem is saying that pair of the corresponding angles are equal, means this one here. This angle here above and this are called corresponding on the same side and above the parallel lines. So that means then the corresponding pair 1 and 2 are equal. That's what it is saying. There will be 4 pairs. So here 3 down on the right side or on the left side and down on the left side. Okay, so these 3, second pair of corresponding angles. Then here also 3, 4, 5 and 6, let us say. So this is angle 5 and angle 6. This angle here 5 and 6, they are corresponding. Then here one more pair is there, 7 and 8. So this, if two parallel lines are cut by transversal, there are 4 pairs of corresponding angles and they will be all equal. Okay, that's what this theorem is saying. Okay, now let us go to the next one. 1 and 2 is, I think, the converse of this one. So let us do that. 2. In this class, we'll discuss the theorems that we're going to use in this exercise. Okay, and there will be no test for this. Next one, converse, I think. If a transversal intersect two lines, if a transversal intersects, right along with me, intersects two lines such that one pair is enough, okay? A pair of corresponding angles, a pair of corresponding, we can write in short, corresponding angles are equal. A pair of corresponding angles are equal. Then the theorem is saying, this is the the converse of the one we did in 1. 1 is two parallel lines. If it's cut by transversal, then the corresponding angles are equal. Here the corresponding angles are equal, then the lines are parallel, the reverse or the converse. Then the two lines are parallel. The two lines, these two same lines are parallel. What does this mean? Draw along with me to understand. Two lines are given, let us say A, B, C, D, cut by a transversal EF at G here and H. So what this theorem is saying is, if EF, the transversal EF, or you can just write transversal also, if the transversal EF intersects AB and CD at G and H respectively, then respectively, such that the condition is such that any one pair of corresponding angle, that means this and these are corresponding up on the right, 1 equal to 2, or it can be 3 equal to 4. Any one pair is enough. Such that 1 is equal to 2, then this theorem means the corresponding angles are equal. Then the two lines there, AB, will be parallel to CD. Okay. Now, let's go to the third one. Write it down. The third one. Third one is, if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. If a transversal intersects two parallel lines, then each pair of alternate or alternate interior angles, also you could call them, or alternate angles simply, is equal. There will be two pairs, I think. So here, what does this mean? It means this one. Two lines are there which are parallel, let us say. And then EF is the transversal cutting AB at G, let us say, and H, draw it. Then if transversal, the theorem is saying here, EF, okay, we can just write the parallel first. If AB parallel to CD and transversal EF intersects AB and CD at G and H respectively, then all the pairs of alternate angles, interior alternate angles, here means inside here, one on the left, inside here down, okay? These two are alternate pairs, they are the corresponding pairs of alternate, will be equal. And here also 3, here, inside right, inside left, inside the parallel, not up, outside, but inside. So 3, these two pair of angles are called alternate interior angles, or simply alternate angles, and they will be equal because the lines are parallel. Okay, the fourth one. Write down fourth. Here, this is the converse of the one we did just now. If a transversal intersects two lines, if a transversal intersects two lines, okay, intersects two lines, such that a pair of alternate interior angles are equal, then the two lines are parallel. Okay, two lines are parallel. Now here, what does this mean? It means this here. Two lines are there, A, B, C, D, cut by a transversal E, F at G, let us say, and H here and here. So if the transversal EF intersects AB and CD at E and F respectively, such that this theorem is saying such that a pair of alternate interior angles, so any one pair here, here maybe, 1 equal to angle 2, then surely those two lines in question, B and CD, will be parallel. That's what this means. Okay. Then the fifth one. The fifth one is if a transversal intersects two parallel lines, if a transversal intersects two parallel lines, then each pair of alternate, each pair of alternate interior angles, but they are on the same side, on the alternate interior angles, each pair of, okay, not alternate, sorry, each pair of interior angles, each pair of, alternate is different, each pair of interior angles on the same side of the transversal, side of the transversal, that is, this is also called consecutive, you can write down consecutive interior angles, or they are also called allied angles, or they are also called, okay, allied angles, or they are also called consecutive interior angles, allied angles, or co-interior angles. Yes, co-interior angles are supplementary. Supplementary means together they will make 180 degree. Supplementary. So here, what does this mean? Let us draw the diagram to understand. There are two lines which are parallel, let's say AB and CD, cut by a transversal EF at G and H, let us say. So if AB condition is must be parallel, the two lines must be parallel, and transversal EF intersects AB and CD at G and H respectively, then what happens is this, look here, interior angles on the same side of the transversal means this one inside on the right side, 2, this 1 and 3 here are alternate angles, but 1 here, both interior on the same side of transversal, that is called consecutive interior angles, or allied angles, or co-interior angles. So those supplementary means together, means plus, will be 180 degree. So another pair is here, 3 and 4 on the same side, interior angles on the same side of the transversal, 3 and 4, this side, this is exterior, this is interior. supplementary means this is what they're saying. Together will be, so these two together 180, these two together 180. Okay. Now two more theorems are there. So next one is converse of this one, 6. Here it is saying if a transversal intersect two lines such that if a transversal intersects two lines such that, okay, if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal. Here the meaning is the co-interior angles or the allied angles, or they are also called as the consecutive interior angles. Any of these three is the correct name. A pair of these co-interior angles are supplementary. If they are supplementary, then the lines, the two lines are parallel. That's what it means. So what does this mean? Let us do it together. This means here, suppose there are two lines given to us cut by a transversal EF, a G and H, let us say. Two lines given are AB and CD, let us say. So if transversal EF intersects AB and CD, the two lines at G and H respectively, such that a pair of interior angles on the same side, this can be the two interior on the same side, there's this co-interior angle, angle 1, if they are equal to 180, then this theorem is saying then these two lines AB will be parallel to CD, the converse of the 5 that we did just a moment ago. The last theorem in this exercise that we'll be doing is 7. So we can write it down and we'll explain it together. Lines which are parallel to the same line are parallel to each other. Lines which are parallel to the same line are parallel to each other. What does this mean? Let us do it here. Lines that are parallel to the same line. So let us say AB is parallel to CD. AB parallel to CD, let's write down. So what this means is if AB is parallel to CD and also another line EF, another set of line also parallel to the same one AB CD. See here, this AB is parallel to CD. EF is also parallel to CD. So this AB and EF are parallel to the same line CD. Then those two lines also will be parallel to each other. That's what it means. If two lines are parallel to the same line CD, those two lines AB and EF will also themselves be parallel to each other. Okay, so this concludes. Now we'll continue in the next class. This concludes the portion for this video 4 6.2 introduction. Okay, and we'll start in the next class. Okay.